So guys, in this lecture we are going to study Ohm's law. This is lecture 3rd of electricity class 10th. Ohm's law is very important for your board exams. This is usually asked in your board exam. In every year exam this is asked. Now Ohm's law हमें क्या relationship देता है? Ohm's law basically हमें potential difference basically gives a relationship between potential difference, that is del V, and current potential difference and current. We have studied potential difference and we have studied current. We carried out a series of experiments to show a relationship between potential difference and current. According to this law, the current he carried out experiments like this. Consider a conductor. If we consider a conductor like this is our conductor, and to this conductor we have over here positive charge. This is positive potential. On this conductor, on this side there is positive potential. This is positive potential. Now this conductor contains certain electrons. Now see, positive and negatively charged species attract each other, therefore these electrons will flow towards this positive potential. Let the potential on this side of the conductor, it is 0. There is no potential on this side of conductor. Now I consider a conductor. To this conductor there is a potential of positive charge on this side, and inside the conductor there are certain electrons which are moving, and on this side of the conductor there is no potential. Now this is my V final and this is my V initial. The difference between the two, that is del V, this is potential difference. This potential difference will be equal to then V final, that's equal to V. V final minus V initial. V initial is 0, that is V final. Okay, now see, these electrons will move towards this positive potential. Now there is a convention is that the direction of flow of current is opposite to the direction of flow of electrons. Direction of flow of current, this is a convention, you have to remember this. Flow of current is opposite to the flow of electrons, is opposite to the flow of electrons, is opposite to the flow of electrons. What does this mean? This means that if our electrons are moving towards this positive potential, means towards this side, towards this side, towards this side, our electric current will move towards this side. Our electric current will move towards this side. This is the direction of electric current and this is the direction of flow of electrons. It is opposite to each other. Now Ohm find a relationship between this potential difference and current. How much current will be flowing when we apply how much potential difference. Ohm find that the more the potential difference applied across the conductor, see, more the potential difference, जितनी ज़्यादा यहाँ पे potential difference हम apply करेंगे उतने ज़्यादा electrons यहाँ की ओर move करेंगे. The more we apply potential difference on this side, the more electrons will flow towards this side. The more electrons will flow towards this side, the more current will flow in the opposite direction. Means that potential, if we apply potential across the ends of a conductor, this is one end, this is other end. Applying potential across the ends of a conductor, the greater we apply the potential, the more current will flow in it. That is, if we have more positive charges over here, more electrons will flow towards this side. The more electrons will flow towards this side, the more current will flow in the opposite direction. That is, potential is directly proportional to the current flowing through the conductor. Potential applied across the ends of a conductor is directly proportional to the current flowing through the conductor. Now this is Ohm's law. Then Ohm's law will be stated like this. Potential difference del V, it will be directly proportional to I. What is del V? It is potential difference. Potential difference, a current flowing through the conductor, is directly proportional to the potential difference applied across the ends of a conductor. Now what is del V? Del V is the potential difference applied across the ends of the conductor and I is current flowing through the conductor. Now see how you understand this. जितनी ज़्यादा आप पोटेंशियल यहाँ से लगाओगे, मीन्स जितनी ज़्यादा आप पॉजिटिव चार्ज यहाँ से लगाओगे उतने ज़्यादा इलेक्ट्रॉन्स यहाँ की तरफ फ्लो करेंगे. The more the electrons will flow towards this positive charge, the more will current flow in the opposite direction. Means the greater the potential is, the more is the current flow of the current. That means del V is directly proportional to I. Means this del V potential difference is directly proportional to the current flowing. It means that if you double this potential difference, if you double this potential, current becomes doublet, I becomes doublet, I becomes double. Or if you make this potential 3 times, I becomes 3 times. It is directly proportional. If you make it 10 times, I becomes 10 times. Means it is directly proportional. What can you get from here? You get a graph from here. Graph between potential difference and I. Let this is my potential difference del V and this is I. When you increase potential difference, your current increases, or when you increase current, your potential difference increases. Now the graph will be then a straight line. Why it's a straight line? We will check it. Now see, this is 0 of the graph. You increase current, that's 1 ampere, 0.1 ampere, 0.2 ampere, 0.3 ampere, 0.4 ampere, 0.5 ampere, and to this side potential increases. When your current is 0.1 ampere, your potential is directly proportional to the current. Means it is, for example, it is 10 volts. When your current is 0.2, you increased it, this becomes double. Double means 20 volts, 30 volts, 40 volts, like this. This is the interpretation of this law. Del V is directly proportional to I. Therefore, we can summarize it. Ohm's law states that potential difference applied across the ends of a conductor is directly proportional to the current flowing through the conductor. Potential difference applied across the ends of a conductor is directly proportional to the current flowing through the conductor. The law may be stated as, we can state this law. It states that the potential difference that is del V applied across the ends of a conductor, is directly proportional to current flowing through it, That means that is del V, that is potential difference applied across the conductor, is directly proportional to I. Now let us move this equation forward. Whenever there is proportionality, we have to use equality sign in place of proportionality. Now using equality sign, we get del V is equal to R into I. Now what is R? R is constant. Remember, R is constant. This is important thing. R is constant. It is constant of proportionality. R is constant of proportionality. And it is called the resistance of a conductor. It's called the resistance of a conductor. Now see, our equation is V is equal to IR, or V is equal to RI. Now we are going to plot a graph of this equation. Now see, this is equation of the type y is equal to mx. Now y is equal to mx. We treat this v as y along y-axis and this I along z-x-axis, and this m is slope. When we have an equation of this type, y is equal to mx, wherever you have an equation of this type, y is equal to mx, it gives a straight line graph. Wherever you have an equation of this type, y is equal to mx, it gives a straight line graph passing through origin. Graph between what and what? Graph between y and x, and this m is equal to slope of the graph. Slope means that is tan theta. tan theta. You can determine this slope from tan theta. For example, you might have studied number of equations in physics. For example, we have studied that acceleration is equal to velocity by time. Can we write it like this? V is equal to at multiplying t over here. Now this is equation of the type y is equal to mx. If you plot a graph over here between v and t, you will get a straight line between y and x. V is our y, x is our t. You will get a straight line whose slope will be acceleration. Wherever you have an equation of this type, you will always get straight line passing through the origin with slope. Similarly, if we plot a graph for this equation y is equal to mx, this is my y-axis, this is my x-axis, graph will be straight line. Graph will be passing through origin, this is origin, and slope of the graph is equal to m, this is slope of graph m. Slope means it is tan theta, this tan theta. You can determine it over here, you can determine it over here, you can determine it over here, you can determine it anywhere. That is tan theta, this is m. Now see this equation, v is equal to ir, v is equal to ir. Better term is del v is equal to ir. Now see, this is my y-axis, this is my x-axis, and this is my slope m. It's equation of the type y is equal to mx. Now y over here is del v, means y-axis, on y-axis I have to plot del v, that's potential difference. And on x-axis I have to plot current, that's I. Towards this side current is increasing, towards this side potential difference is increasing. What will be the nature of the graph? Y is equal to mx, graph will be a straight line. It will be passing through origin, this is origin. Means if you increase current, potential difference increases. This graph indicates that potential is directly proportional to current. You are going to increase current, potential difference increases. Means this is potential difference, add this current. This is current, add this potential difference. This is current, add this potential difference. You increase current, potential, you increase potential difference, current increases. Now what is R? R is equal to slope of the graph. You can find this R from the slope of the graph. This is the slope of the graph, that is theta. You can determine from here, you can determine R. From here you can determine R, that is slope, it is equal to R. From here you can determine R, that is slope, that's equal to R. Now see, this is Ohm's law. This is the graphical representation of Ohm's law. This is very important. Graphical representation of Ohm's law states that if we plot a graph between del V and I, that's potential difference and current, we always get a straight line which passes through the origin, and we get the slope of the graph, that's equal to tan theta. From the slope we can determine resistance of the graph. Now see, very important thing, new term over here is this R. This R is equal to resistance of a conductor. Resistance of a conductor. Now very important, resistance of a conductor. If I determine R over here, R becomes equal to V by I. What is V? It is potential, its unit is volt. What is current? What is I? It's current, its unit is ampere. This is volt per ampere. It's called ohm, and it is represented by omega. This is called ohm. SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistance is ohm. That's volt per meter per ampere. It's called ohm. Now see, according to this relation, resistance is directly proportional to potential. Means if you increase potential, resistance should increase. Resistance is inversely proportional to current. Means if you are going to increase current, resistance should decrease. But this does not happen. Resistance is the property of material. Resistance does not vary with V and I. Resistance is the property of material. It does not vary with V and I. This equation को छोड़ो. इस इक्वेशन से आप गलत कर सकते हो. रेजिस्टेंस ना पोटेंशियल पे डिपेंड करती है, नहीं ये करंट पे डिपेंड करती है, बिकॉज यू ऑब्टेन इट फ्रॉम द स्लोप. दिस इज सेम एवरीवेयर. Resistance is a property of a material. This is very important. Resistance does not depend upon potential. Whatever potential you increase, resistance has no effect. Whatever current you are passing, resistance has no effect. Resistance depends only upon nature of the conductor. It only depends upon nature of conductor. Resistance depends only on nature of conductor. This is very important. Nature of conductor. It depends upon nature of conductor. What do we mean by nature of conductor? Means the length of the conductor, the area of cross section of the conductor. Now if you double the current, what happens to the resistance? Nothing. If you increase the potential, what happens to the resistance? Nothing. If you increase the potential, resistance should increase, but this does not happen. If you increase the current, resistance should increase. Resistance should decrease, but this does not happen. Why? Because it's the property of a material. It is a property of a material. It depends upon the nature of the material. It depends upon the nature of the conductor. Resistance depends upon nature of conductor. Now, how resistance depends upon nature of conductor, we will start it in next lecture. Thank you for watching.